good morning, good afternoon, or good evening whenever you're starting up our physics document here, physics lecture here on units, conversions, algebra, and trig. So this is going to be the basic setup for most of our lectures here. You're going to start with objectives, and then we'll start up the class activity. We'll have different rounds. I'm going to do my best to speak a little slowly just to make sure you can hear me well on these videos, as well as maybe just taking my time on writing. If things are going a little slow for you, you can always click that, times 1.5 times 2 in terms of the speed. But I want to make sure that I'm understandable. Physics is already hard enough, right? So here's our objectives. I'll let you read through those, but pretty much we're going to be doing units, conversions, algebra, and trig, learning a little bit, or reviewing, I should say, hopefully, that math foundation for the course. If this ends up being a little difficult for you, I'm not saying to rethink taking the class, but that's going to give you a good feel for if you have to relearn the math or blow the dust off of your math brain. You're going to have to be doing that on top of learning how to apply it, because this is a physics class, not a math class, right? It's applied math. So let's go ahead and we'll start up with round one, which is symbols, which I really should say is learning how to talk like a physicist, right? We're about relationships. And when we are solving problems, it's not about necessarily getting the right answer. I know that's really important, and you'll be tested on that on the exams. But it's about the relationships between physical quantities. So when we're solving problems, particularly in class, we're not going to be using numbers, right? We're going to start with variables. And even though we say some variable, like we'll get to this in an example, when I say a variable such as x1 or x2 or v1 or v2, that doesn't necessarily mean it's an unknown value, right? So let's just go ahead and we'll get started with symbols. Okay, so in physics, we have some pretty basic physical quantities we're all associated with: time, length, mass, velocity, acceleration, force, angle. And there's all sorts of different symbols when we go through this whole physics class, maybe next semester as well, where when we are writing problems, instead of saying time, we'll say at time t, right? Or time big T, or mass m, right? So we're going to associate a variable with that physical quantity. Now, some are pretty straightforward. Mass is m, velocity is v, but then we have others. For example, let me get some highlighting going here. Length, it could be L, it could be D, it could be X, it could be Y, it could be capital L, it could be R, right? It could be all sorts of different symbols. And then we could also just have, hey, I'm just going to use little t for all times, but let's say I want to compare two different times, an initial time and a final time, a time before and a time after. And then we start saying, okay, I'm going to make that distinction of those two different times with two different numbers, and we use subscripts with that. We also use Greek letters as well. Talk about angle particularly. There's theta, alpha, beta, phi, fum, right? So alternatively, we could also say theta 1, theta 2. Okay, so you'll be seeing all sorts of different symbols. Try not to get overwhelmed by the symbols, right? The symbols just are related back to a specific physical quantity, right? Sometimes it can relate to an unknown. We don't know that value. I'm trying to find it. Other times it can relate to a known value of a known size and unit, right? Time could be 3 seconds. Time could be 3 minutes. Time could be 60 hours, okay? All right, so let's just kind of basically starting off here with symbols. There we go. There we go. So let's start working off with an example where we start to speak the language with symbols, and how does that correspond to speaking with numbers. Right, so the car is a length x. That's what I would say if I'm speaking symbolically. That x could refer to a car that is 10 feet long. I don't know, we could call that a truck or something like that. Or it could be a length x where it's 50 feet long, and I'm talking about a semi. Point is I'm speaking generally, right? I could tell you this depending, and it will be different depending on what car I'm talking about. Or I could just say the car is a length 4.5 meters. Okay. The left side symbolic is the same as the right side specific numeric. Okay, that's what we want to get you through, right? The car is a length 4.5 meters. Okay, that is a distance, that is a length, that is some sort of x variable, right, that I can use in my solutions as I'm trying to solve for something. Okay, we could then go up one little iteration, right? Symbolic. At time t1, the car is at position y1. Notice, like, if I were to speak that, I'm speaking as if I know these values, right? I'm not saying, at this time, where is this thing, right? No, I'm saying at this time, t1, the car is located at a particular position, y1. So you have to infer from what the sentence is saying. So the other thing I will probably try to make note here is, you notice t1 in y1, right? T is a time, y is a position. They both have the subscript 1, which means they're linked to each other. This is my position at this particular time. The two go together. So if I spoke this in terms of numeric, I would say, at 3.1 seconds, the car is located at position 5.9 meters. Okay. The symbolic is saying the same thing in a general fashion. You know the car's position at a specific time without giving you those specific numbers. Okay, let's check out this next little example right here. I'm going to put the star next to it. If a car is located at x1 at time t1, that sounds very familiar to what, or similar to what we had up above. If a car is located at x1 at time t1, what is the location x2 at time t2? Notice that has a question mark on it. That means there's something in here we don't know, right? So there's 4 variables. 3 of them are quantities you know, and 1 of them is not. So give yourself a little bit of pause and try to solve it. All right. Ready to move forward? Let's see. There we go. So x1. Do I know the value of x1? If a car is located at x1, okay, at time t1. So this is me saying I know where it is at that particular time. If a car is at x1 at time t1, what is the location? So when we say, look at this, what is the location, right? That to me is just like, where is the car? Donde es whatever the car is. Sorry. But you guys know what I'm trying to say here. Where is it? No. What is the location? Where is this thing? At time t2. So I know the specific time. Just like at this time, where is this darned thing? So I don't know where it is, but I do know why. I do want to know where is it at this particular time. Now if we try to go through this and rewrite this with a sentence, right? I'm going to type this out so it might go a little fast, right? If a car is located at, I'll just say 50 meters at time 3 seconds, what is the location x2 at time, let's see, 3 seconds, has to be after 3 seconds, so I'll just say 10 seconds, right? That's what this would be like if I put numbers in it, right? So try to make 2 ways of saying this sentence, the 2 ways of saying this sentence, right? If a car is located at x1 at time t1, what is the location x2 at time t2? Try to make that as fluent, you could say, or as second nature as I write, as saying if a car is located at 50 meters at time 3 seconds, what is the location x2 at time 10 seconds? Now, sometimes when you're speaking, you may not say x2, right? But here we're just trying to really be specific, general. What is the location at time 10 seconds? What is that second location that I'm looking for, right? If you can speak generally in this, hopefully once you get to your field of choice, you'll have to speak generally as well. The other big benefit of being able to speak generally and solve problems generally is, there's a couple reasons. One is if you have the exact same question, hint that may or may not happen on the exam. I've seen this question before. It has different numbers though, so but I've solved it already from a general perspective, right? That means you've already solved it. The other thing you can do is there's a lot of algebra in the class. So if you solve a question algebraically and you do a unit check at the end, you can see if you did your algebra right. Most students probably don't care. If you put the numbers in, you can always carry the units through as well to do your unit check at the end to check your algebra. But again, practice shows me, most students don't put units in with their numbers, though that is a good practice to do, right? But try to make this a second nature before we get to really rolling into the class, right? So you're not trying to understand what the heck the problem is saying in terms of what do I know, what do I don't know, what am I trying to solve for, as opposed to trying to figure out what physics you need to apply.